Hello students, this is Dr. Prakash Pitroda, and in this session functions and its types part 4 we are going to discuss more about scope of variables, which is going to be quite useful for your functions and constructors. Let us begin with the revision of what we have done in part 1, 2 and 3. All those who have not gone through part 1, 2 and 3, I suggest you that you should go to part 1, 2 and 3 before you read, or rather say going through the part 4. It will be more useful then, it will be more meaningful. Let us start with part 4. So here in the revision, let us quickly understand. We have learned functions and its types. So the meaning of the function has been learned by us. Let me just start the pen over here. Yeah. So we have learned meaning of the functions. What we have understood: functions, method or module all means same, which is nothing but a task or a process from a large program. We divide the large program, we break the program into small and easily executable tasks. We call that as functions. Then we have understood different types of functions. There are two basic types of functions: your library functions, which are ready-made functions supplied by Java, and the other functions which are created by the programmer for the specific needs of the user. We call them as user-defined function. We've also seen there are two types there: call by value and call by reference. In ICC, you will get a 15-mark question of programming on call by value as well as 15-mark question of programming on call by reference. In call by value also, there are two different types of functions being asked, one being void type, another is return type, which we have seen in the previous parts. However, we will quickly have a revision on this. So what we have seen in these two type function, the void type and a return type, in the revision, what we understand is, let us start with the void type first. In a void type function, you will have a word void being written in the function prototype, the first line of the function, where you may have whatever parameter the function name, but the return type will be void type. Void itself means does not return. Return means after the value is calculated in your process, the final value is not supplied back to the function call. These are your two function call statement, you can see. Alright, their job is to execute this function in some logical order. So here sum of 1.0 comma 2.0 will call this function over here, hand over these two values to A and B, that total is found, and then they are printed. Void type is expected to either store a value, print a value, or both. So your product also, product function is called here, 2 and 5 has been supplied over here, and the calculated value directly printed on the screen because it's a void type. Whereas corresponding to that is a return type, or rather say a reverse of that or opposite to that is a return type. The word return itself tells you that return means once the final value is calculated of a particular process, this value can be supplied from here to the place where function call was made. So function call is made over here. Alright, so the value that is been supplied. So for example, if I'm calling a function sum 2.5 comma 3.5, so 2.5 and 3.5, this function is called here, 2.5 and 3.5 is supplied here or handed over here. Their total is found, that's 6.0. This means return 6.0, not the C, but the value of C goes back and this entire thing becomes 6.0. It's a job of a print statement to print that onto the screen. So return type supplies the value back. I suggest you to go through part 2 for this particular session in detail. I have explained that in detail in part 2 in functions and its types. So this is how the function is returned. Since the function is returning, you cannot write a void over here. It has to be either the equivalent type of the value that you are sending back or supplying back, or a greater than this. So the details are there in function and its type part 2. Similarly here, public static int, it's not void, it's int product. So product function is called. Alright, this function is called here. This particular function is called here. The values has been copied here, 2 and 5. 2 into 5, that's 10. So return 10 will return the value 10 over here. So once the value is returned back, these values can be either stored or can be printed depending upon the needs of the programmer. So as a programmer, you have to decide what to do when the value comes back. So logically, the job of a return type function is to calculate the process value using a function, return the function, the processed value back to the function call statement, let the programmer decide what is to be done further with this. Then what we learned also after this is the function overloading, which is one of the type of a program that has been asked for several years of 15 marks. So this is of course an example. So here what we do is you have multiple functions having same name. So void sum, and void sum. So multiple functions with the same name, alright, or we can several functions with the same name, but they are differentiated by the parameter list. Now if you look at this, there are two integers, alright, whereas there are three integers. So there is a different parameter. There are two integers, or even if the number of arguments are same, then they are differed by the you can say data type. So if you compare this one with this function or this one with this function, then it has two different types. That is, in the first case, if I number this as a first case, you have two integers. In the second case, you have got three integers. So it is differed by parameter list with respect to the number of arguments. That is, there are two arguments, there are three arguments, or it is differentiated by the data type of the argument. Alright, so here they have two integers, here you have two decimals, alright, and then of course the processes. So in that case, you will see the overloading allows you to have multiple functions with the same name, but they are differentiated by its parameter list with respect to two things. One, the data type of the arguments, and the second one is the number of argument. Here is a number of argument, this is a data type. Okay, and if you want to call, so computer programming, your Java language is smart enough that when it reads sum of 5 comma 10, it will go to this matching, that is 5 and 10 are technically two integers. This is integer, this is integer, so this is going to be called by, alright, by this function only because they are two integers. Sum of 2, 3 and 5. Now if you look at it, there are three integers, integer 1, 2 and 3. So it is being called by this particular function only. Sum of 4.2 comma 3.0 will definitely match with two decimals. Alright, so it will be called by this function only. So your programming compiler is smart enough to identify the type of data and call the matching function only. Then in case you have one integer and one decimal, then also computer will use this particular function to call, because 3.0 is technically a double value, but 2, which is integer, can easily go, computer will use the implicit cast in order to go through this. For implicit cast, you need to go to the Java token theory. Alright, there are 3-4 parts over there where you will find somewhere there is explicit and implicit cast. You will understand that computer will convert 2 into 2.0 and convert and call this function only. So as if the function is first one decimal and the second one integer, the same logic apply. Is this is double, which will go into A because that's a double type, whereas 4 is integer, which is going to be converted into 4.0 by computer using method casting, and then computer will call this. So this function will automatically call those functions only unless there is a specific function of public static void double a int b or int a double b, then only they will be using this. Again, this is there in your part 3 of functions and types in detail, so you can go through there as well. Now we are going to move further ahead understanding this concept. So you need to pause the video over here and you need to identify what will be the output of this program, or rather say, will this program work? If yes, the output. If you think yes, you need to know the output, and if you think no, then you need to have a reason, a logical reason, or rather say logical reason why this program will not work. Alright, so you need to pause over here talk to yourself, identify whether this will work or not, and let us go to the programming section to understand and identify whether this will work or not, why it will work and why it will not work. All right, so I'm taking you to the programming section. So there we go. Alright, so we are going to start with the programming section over here. Let me see, where is my function over here? So it's not here. I think it should be here. Okay, so I'm going to convert this particular program into what the question was asked to you. So I'm going to just keep it over here simple for us to understand. I'm going to make this to 10 and I'm going to also delete all this over here just to make us understand whether this will work or not. Okay, and I'm going to also write down over here, copy and paste over here. Okay, so yeah, capital S. So as a programmer, if you have a look at this, you will be understanding that when I'm going to try and compile this program, there is int 1 to 10 is given, print I, but this program, the moment I compile, will give me an error message in this line saying the cannot find symbol variable I. Now you need to logically understand this. You may have learned somewhere in your past in your programming section as well, that when a variable is declared for a particular pair of brackets, so logically your I is being declared for this bracket. So it's only available in this bracket, it's not available outside. That's why it is telling you, or it's rather say giving you the error message, cannot find symbol variable I. The number of places you will find this particular concept. Once a variable is declared for a particular pair of bracket, which is we also call it as a block. From here to here is a block. If a variable which is declared for this block from here to here, it is not available outside the block. Alright, so logically this is called scope of variable. Scope, how far I am able to use the variable, is called scope of variable, and this is very important for us to understand constructor further. So for that we are going to first understand the concept and then we will move on to the next part. Scope is we say is the program region within which a variable is accessible. Accessible means I am able to use that variable. I am able to apply the value of the variable, right? So how far I'll be able to use this, that's called in a simple term a retrieve you can call. Now scope of variable, there are two types of scope that you have, the local scope and the global scope variable. There are two types of variable that you have in your syllabus that you say. Alright, in local scope what we have just now learned, I will again revise this. Global scope, again they are of two types, they are called static variables and they are called non-static variables. Static variables are also called class variable. We will discuss each of them in detail in the next few slides. And instance variable. Alright, so this is your basic division of scope, how far I can use. So let us start with understanding the local and the global. So understanding the local scope first. So local scope, what we say is if the variable is declared and used and accessible within the pair of braces which we call block. So in this case your block is from here to here. So this is a boundary within which C is available because it's being declared inside, and I is being available because for I is for this particular block only. So I and C both are available only for this block. They can't be used outside. This is not going to work because this is local. It is only for this particular thing. Similarly, in a condition also, when you are writing a condition and if you are defining something inside, declaring rather say a variable with its data type, alright, then you cannot use this outside. This variable is not available here, you will get an error message. The error message will come. Why? Because the variable is being accessed, being available, being used outside then the block. So I cannot use this beyond this. So in a worst situation, if you have to, then you also need to write system.out.println this over here. This statement should have been either here, or rather say here and here both, otherwise it will not work. Similarly, if I want to make use of C, it has to be inside, but then inside, if you are going to write C, every time the loop repeats, the value of C will keep on printing, depending upon your use, on your use. So as a programmer, you need to know that yes, a variable can't be used, even variables to declared in two different functions also, the methods also can't be used in each other if they are declared inside. Okay, whereas we talk about the global scope. Now in global scope, concept is very clear. In global scope, if you look at this, here is a class boundary. This bracket is a class boundary. Here is your void sum. Here is your void display. I have not written the complete function. This is an example. Now if you note down this is an important line. This is where you are declaring these variables. The variables which are declared within the class bracket from here to here, they are declared within the class but outside all the functions. We call them as global scope variable. Of course, we are going to learn two of them. There are two different types, static and non-static. Alright, for the time being, to make you understand, static, you will write the word static like you are writing for other method, public static void something. Similarly, here also you can use static int abcd, or you can use without static. So there is no, the non-static is not a keyword, static is a keyword. We will again discuss both of them in detail in the next session, rather not in this session. But once a variable is global, the variable can be used in all the functions. If you note down here that I can use ABC over here, I can use ABC over here also. I've just used A. I could have used here B as well as C as well as, I could have used B also, C also with a print statement. Okay, here also for product I can use AB. Here I am using D because even that is a global scope. However, I have declared int x inside void sum. Alright, it's not required, it's just for the learning sake. This is my local scope. Now if I try to use variable which is declared in one function, try to use in another function, I'll get an error message because it's a local variable. But I can use A, B, C, D, even here also I can use A, B, C, D for print. I am allowed because these variables are available everywhere now. I can use them as if they are local for these functions. Alright, so in this case, once the variables are of a global scope in nature, the good thing is now I do not need to pass, though you are allowed to do, not that you can't, but I don't need to pass a value. I can directly use them as they are belonging to the function only. So it becomes very easy for a programmer to perform a task. Now you will see your program is further divided as, you can say here declaration, you can call here as process, I can say process 1, you can say here print or display, you can say, I can have here process 2, I can also have, sorry, process 2, I can also have somewhere in between here even input function as well. So if you look at the program is further divided, your introduction said that your methods will help you dividing a larger program into small and easily executable functions. So you'll find here in this particular session that declaration is separate, inputs are separate, processes are separate, and output is separate. And then of course to run all of them I'll be needing a main function. Okay, main function, and we will see that in a practical session. Okay, so this is where the global scope is. I hope everybody understood the meaning of global. I can decide, I can define here, I can define here, which is outside all the functions but inside still the class. It is not necessary that they have to be defined in the beginning. It can be defined at the end also, in between also, but they can't be forming a part like x. They can't be forming a part of any function, then they become local. Okay, so let us understand with the help of a practical session. So here is our practical session. So I'm going to see here same program. We are going to say here we've got now three different, four different rather say variables. So here is a declaration, this is your comment. Alright, so here we have used the word static. The difference we will see in another session. So right now, since we are used to it, I am just declaring, showing you as and when we progress, we will do both the types, the static and non-static both. Alright, so here we have declared all the variables over here. I have a function input where I am using public static void input. Alright, I am using of course the scanner, because of scanner is there, we have got java.util. Now if you look at it, x and y, I have not done int or anything over here, is being directly used because they've been defined on top. Now user can input a value, okay, the same values can be added, same values can be printed as well, okay, same values can be multiplied, the x and y value. So you have input declaration, okay, you have input, you got process. I can write process anywhere, it's not necessary they have to be in some order only, you can always add a function also in between, okay. So process here, display is also there. Very important for a programmer to understand is that in your main, again if you recollect, we have done in the past that practically in a professional programming, main is not in the same program, main is supposed to be somewhere else. Alright, in another class only, which will be useful, which will help us understanding the abstraction as well in future. But here in your ICC syllabus, it is inside the same class you will be calling. So in your main, when you write input, because you have a function in the name of input here, then computer will execute this function, which will allow user to input two numbers in the form of x and y. Immediately after that, some function will execute this part, which will add the input x and y value over here. Then you have a product function whose job is to run this, which will multiply the input values, and display will display what has been done. So if I compile this, it shows me okay, it shows me no syntax error, you can see here. I close this program and I run this. So in my void main, you can have all voids, but ideally we will run the void main. Again you can see here integer being asked, so I put 5, I press enter, I put 7, I press enter, and you see here x is being stored as 5, y is being stored as 7. 5 plus 7, the sum function may have worked, the product function may have worked, and the display must have definitely shown all three of them. Alright, so if you want to see, I can also add a statement saying that what is happening at each stage. So if I'm going to take a copy of this particular line and I'm going to display it over here. Alright, display it over here just to understand that whether it's going to work or not. Okay, so I'm going to say system.out.println you are in input function. So user will get this message before the input function will start running. Okay, then I'm just putting it over here to show you you are in sum function. Okay, even here also I can add you are in a print function, and of course we are going to say you are in product function. So when I'm going to run this program, when input will run, computer will tell you you are an input function and you will be allowed to enter two values. Some function, when computer must be running, you will get a note, alright, a line saying you are in function. So you know the function must have executed. So as for the product, alright, and then for the display, and you will see the output. So let us say if I'm going to run main, it tells me you are an input function. So this time I'm putting a number, say 12 for the x and 15 for the y. The moment I'll press enter, some product and display all will show me there running. So after I input, alright, input the function, you have been, I don't know why this is printed, we'll check it out. but you are in a sum function. The sum must have added the value, product function must have found the product of the number, and a print function has printed those values of 12 plus 5, 27, and 12 into 5, sorry, not 5, 15 into 15 is 180. So I hope you guys have understood that once the variable is of a global type in nature, I don't know why, okay, there is a statement over here, that's why. All right. So I hope we all have understood that once the variable is of a global type in nature, it can be used directly in each and every type. Alright, or rather say each and every function. So that is the advantage of using global scope. I hope you all have understood this particular concept, local scope and the global scope. Alright, we have seen this using practical scope. Now this is going to help us understanding the constructor in the next one. Until then, thank you very much. I hope you have understood this. If you have not subscribed to my channel, please do subscribe to my channel. I keep on loading or uploading rather say some of the videos for your benefit and your help, which is free of cost. So you need to take that advantage. Thank you very much. God bless.